Okay, let's see if there is something happening here. Will there be some kind of live? Yeah. Okay, it seems we could do it. Okay, let's see if there is something happening here. Yeah. Okay, I'll just really quickly explain, or not quickly, I'll actually be quite long. I'll just want to show you what I have so far. This is the Parfit Next frontend, and it will have a button that connects to the Parfit backend at Dell 05 via vect sockets. And basically right now it's not even a functional chatbot because you cannot interact multiple times, but I can do something like this. Can you do a 5-minute timer please for push-ups? And then there will be these events, and I will now explain what these events are and how they function, because they're not just ordinary events. They follow a tree structure. If you have a computer science background, it might be very simple, but it's otherwise a bit complicated. So we have this idea of an event. These events can be of different types. There's something called a chat completion tool schema scope. There's something called a scope chat completion tool schema. There's something called a tool call execution policy. There's something called a user text submission, a request non-streaming assistant message, an assistant message generation started event, a non-streaming chat completion, a tool execution result, a request non-streaming assistant message a generation started event, and a non-streaming chat completion. So when I just say, hey, how are you, there are a lot of events of different types that are involved here. And those I will markate as green. So there will be these little green things, and then they will be encapsulated by something called an event container. And the event container is a node in a tree. That means they point to a previous event container, and this event container points to a to a previous one, and it might be that it actually points to nothing if it was the first event, but it always has some kind of identity that makes sure that something can point to it. And it does not need to be a chain necessarily, and this is both a problem for applications and a advantage. It allows for a more increased complexity of these systems. So now we have the basic setup, and the green ones are events. They have different types that are encoded by the Parfit system, and it should be possible at some point to add your own kinds of type of events, and they're all encapsulated in an event container. And the thing is, they are based on hashing. So there's a current hash. This means that if I start this thing with an event and it looks like this, then any event that looks like this will have a specific hash, and it will be then look at the previous hashes. If it's nothing, then it will just use the hash of this and generate this. Now this scope chat completion tool schema, it points to the previous thing, 3CD. Well, this is this one. So here we are in a relationship like this and this. And how do we know what the hash of this thing is? 1EBB. Well, it uses the previous hash, then it takes the hash of the whole event, and then it combines those two hashes and uses a hash function to generate the next one EB. So now we have a client. This is a browser. It could also be an iPhone app that will have a bunch of events that is stored. These are 12 events that are stored on the client in a client browser WASM application, where we store the events so far. The client here generates a lot of events. It says, I want to start a new scope. This means like a thing that I can add a tool to. Now I will describe this kind of tool that I'm interested in making available to an agent that can start a timer. You have to specify the number, the type of seconds, number of seconds, and some label of the timer. And you can also use a tool called list exercises that I will also add to the scope of tools. Then the client will tell that I want that when an AI wants to execute a tool, then the system should just start using these tools and get the result of calling this tool. And the client is now, this is how it's implemented. It is generating this event, it's adding it to its list of events, and it is sending it to the backend, to the server. So now the backend will know. And once it has done this, then it will also send the message that the user sent. Can you do a 5-minute time, please? As a specific type of event. This is a green thing. It's a user text submission. And what will the server do? Well, it will just wait because we have different types of applications. Some applications we might want that the user can submit a lot of things, and we only want an AI response at some point when we are ready. Here the client says once we have given the server this thing, we also want to just have a assistant response that is not streaming, it's no sound or anything. And then the backend will see this thing and say, hey, there is this node here in the tree. We are encoded. We have the Parfit system is such that if there's a request, then we should follow up on that request. And eventually it should be that inside this request, here, maybe it's here, that it says, I want to use this AI model or whatever. This is the next step. But right now it just starts immediately using DeepSeek. It then goes, this is the request. It goes backwards up the Parfit tree, following the arrows. And so far it's like a linear train, right? Like this BF, it will go here. Then from BF, it will go to D8, it's up here. And we'll see, oh, there's a tool here. Oh, there's a tool here. Oh, here it starts the scope. I did not see any closing of these scopes, so I will use all these tools. And I also saw a user message. So now I will compile this into a list of a chat conversation that I will give to DeepSeek. Once I have this assistant generation started, I will add it on the backend. The server created this event, and the server sent it back to the client to tell it we are here and we have started. So maybe the client wants to display that there will be a loading arrow or some typing indication or whatever. Then there will be a side effect in the Parfit system that says, now we're not just gonna say that we started, we're actually gonna start it. We're gonna make a side effect in the world that says, hey, we're gonna request something. We're gonna then insert the response. So we allow something else than just the machine to also tell us, tell the system, tell the tree that there is this new event that is called a completion. So now we are adding where someone is coming We do not yet have the tools in the um, in the in the system to talk about who did it, but this will be on the roadmap. Now something added this assistant message that is actually the answer. I'll start a 5-minute timer for your push-ups, blah blah, and it's responding, of course, to this message. Once this message is here, then our system, the backend, can say what is going on. We now have a message. How should we respond? Well, we will look up and find a tool execution policy that says you can just go ahead and execute these tools. Okay, so it does that, and it gets a response from the start timer. And you might say, like, who implemented this tool that says, like, when you call the start timer, the response you get is start a timer at Unix time, blah blah blah, how many seconds or milliseconds it is since some time long ago. That can be used as like an indication of the time that is a bit different like than this. But this will be part of the system that there should actually be some kind of plug-in. So the user in the beginning, when they click start an application, they will not just like add these tools. They will say, I will tell you on the chain, I will put in some kind of node that says not only is this the name of the tool and how the AI should enter which things it should enter, minutes, it should enter seconds. It will also say, actually, when you get this tool start timer, you should go to maybe a server, an entity, some kind of application. And ideally, actually not an external application, but you should actually use a program that has been inserted early on. So maybe, like, if we imagine this is much longer, there was at some point inserted a program on the Parfit tree that describes what is going to happen in this case. In this way, the system will be completely closed off. It will be extremely reproducible. We can always go back in time and see if our system is still functioning as it should, and so on. But multiple options should exist. And this is the idea of side effects, that you can have some kind of side effects that might not be easily reproducible. You cannot know that the ones who are running this DeepSeek large language model, that they will always come back with the same answer or whatever. But and especially, yeah, so there will be this description of how does one run this, but right now it's kind of implemented system like this, that it's just part of the code in a separate part of the code base, that there is some timer that will be called and that will say this thing. Notice that this tool execution result is dependent on the time, and the time is something outside the world. If we go back in time, we start here and we try to execute the tool, then we will get another time. Which means that if you want a system that is very good at handling this complexity of having reproducibility, having good observability, having the ability to run multiple versions and so on, then there should be more design into how we deal with these things. But now there's an external tool, it can say whatever you want. It said that the time was this. Then once we have this, then the tool policy. We have a tool execution policy, linear and immediate, that is just part of this encoding, that once you have executed some tools, you have executed all the tools in this list, there's only one, then you will add a request for a non-streaming assistant message that will follow up on the tools, and this is indeed what happens. We're then getting an event. And this is on the server. The server is saying, after I execute all the tools, I will myself add a node that says we're going to request something. The client could also have chosen to do it. That would then be another kind of policy, that it should not do anything and we should just wait for all the tool events, and the client can maybe see, I saw these tools, maybe I want to present some to the user or whatever. But in this case, the user will then again get a message because we'll go from the request, we'll go backwards up, we'll find all the tools that are within the scope, we'll find all the tool responses, this is a tool execution result, and we will give it all in the right order to the DeepSeek model, and it will say timer set for 5 minutes, your push-ups timer is now running, you got 5 minutes to work on those push-ups, good luck. And then once we have this, we might present it to the user. What is now going to happen next? Well, something is going to have to be responsible for showing a timer. We could do that in many ways, but there are smart and bad ways to do this in conjunction with the Parfit system. The smart way is to say we always, at any time in the world, we just want to look what is the current time and what happened. What happened? Oh, a timer started at this point. And now it is this time. So that means there's this much time left. So either the client can now look, it has access to all this data, and clients are strong enough to do this, or we could implement on the server that the server will have some kind of thing going on that tells, that is aware of the time, and gets the results. So something is computing what is going to happen. But this was like the initial idea. So this is like very concrete probably, but like the larger vision is then that you have this giant tree, and it's not just, as I say, we just add these things. We have specific applications that are running on this tree, so that the tree becomes like an operating system where different people can insert a node, and they decide, everyone can insert a node. They say, hey, I inserted this node, and I'm the owner now of everything that happens downstream. I can authorize by adding a node to say, I want this application, maybe a gym application, maybe a teacher application, maybe a therapist application, that from now on here it's gonna be able to also add nodes. Of course, everyone can add a node, but it would also be able to see when I add a node. So if I say, hey, how are you doing? Then something else will be able to see these messages and actually add a node here that points to this thing, because it knows the node exists, otherwise it would be secret to it. And maybe it would even be encrypted or something. And then we can start an interaction now where this thing says, hey, I want to add these tools now to be available for the user when they talk to me. I want to decide like how we're gonna execute something. Maybe the user says what they're willing to want to execute. And when we start a new conversation, like I can like read up to here when the user authorized that I get access to these things, or it may be actually authorizing me to look back further up later in its history, where maybe it was actually talking to another application, maybe it was an AI that was related to the job or related to something that was personal or not personal. So in this way, there can be a structure where the client can manage the rights and the data, but also, of course, as I said, run applications directly on the chain in a way that is opening up new possibilities. Because if we have this chain, this tree that is structured in this way, where we have strict management of what happened earlier because we are using these hashes, then we can like have applications where you can roll back in time. You can say the user responded this, and then the AI responded this. Then the user will say, hey, I actually did not like what you said. You should have said this. Well, somebody might program a thing that when it does this, then there's something, maybe the AI itself says, hey, okay, the user told me he she or he did not like this. What they didn't like was this thing up here. So this might not be like the hashes, but like some information tells you this was up here. And actually I should have said this other thing. So maybe actually to this response, they add like a little hint and say, the user asks something. When you reply to this message, you should maybe actually think about not using the word like that. You should say something else or whatever. And then that's no help for what happened in the past. But if you roll back now in time, some AI system is like, or some company or organization is now rolling back in time on the user experiences, or maybe the user itself wants the AI that it's interacting with to get better in the future. So now we're rolling back, it's generating a response, but before it's generating a response, we're inserting a hint. Whereas this was the user message, this is a hint. So maybe we're inserting now the hint here and generating another alternative response. So actually it will not be on top of this. There will be like multiple pathways that this interaction could take. And in this case, it is actually knowing that it should not do this error, and it will get a response. And maybe the person who designed the application made it so that the user can literally roll back in time and experience the other response and get some other thing. And maybe even after they said this, then you can do this, you can somehow like say yeah, and then you still make use of some of the things that happen down here and plug it in here or reference it, so that you get a completely different way of collaborating with AI than you would have with another human, because you can explore these different timelines. And not only can humans do these different timelines, training can be happening, not the literal training, the process of making rollouts and storing the data from these rollouts of like generations from the LLM, and the literal evaluations. So not only might you give a hint, from the hints there might be some other application. Some researcher might say like, we're going to use these hints and I will program an application that maybe uses another AI or whatever to generate criteria that is going to be used for judging a response. Then whenever there is a response, some application might look, hey, there is a response here, we're going to go up here and down here and say there's a response here. I'm going to literally reference from within the event this tool, this LLM as a judge criterion. I'm going to evaluate it and I'm going to give you a check mark or a score or whatever. And now these rewards are living on the chain, and then some other system can come by and see, oh, we have rewards for this and we have rewards for this. And we can also say, not only there's a response, maybe it's executing a program, maybe it's living on the chain again, so that we have like very good reproducibility, and say like, oh, I'm gonna do another AI, it's gonna trained on this thing, and now we're gonna reference this and we're gonna come down and try again and all these things. So I could imagine that something that has this very simple structure, just like a very large tree of events, if you are able to provide a sufficiently strong system framework for encoding different computations on this tree, then this can be both like an operating system for these agents, and it's like specifically also very compatible with the causal attention of language models. So when you have a language model and you want to try different opportunities, so you have this and this and this, then you should not, if you want to go here, you should not change something very far up, because then everything downstream in the computation of the predictions of the language model will change. Instead, you should cut off recent things, because then you can reuse a lot of what was computed for the earlier tokens. And there might even be, I don't know, things that can offer to store certain chunks of the conversation for different models, and there is research by Prime Intellect with Toplock that can try to verify that a specific completion is indeed happening by a specific LLM. So maybe one cannot afford this always, but maybe there is a completion here by a DeepSeek model. Something, some app or some provider claimed, hey, I just appended a completion to your messages that was like part of a conversation. If you go up here, and then someone, maybe because some user said, hey, once in a while I want to check, so here I put some money up for offer to check. Then someone is coming here and say, hey, yo, I have a proof that this thing is indeed computed by this thing, by DeepSeek, and I request some of this stuff you offered to check this or whatever. So in general, the conclusion is just like a simple tree structure that is based maybe on just hash chains like Git. It could go very far, and there are many possibilities.